Good morning, students. How are you all? You all are okay? I think you all are okay. Now today I'm going to introduce a new chapter, that is complex number. Today's our new chapter is complex number. So before starting complex number, I want to remind you that in class 10th, we all have studied about real numbers. What is real numbers? So we can say that a real number is a set of rational, irrational, integers, and that's so on. That means a real number is a full set of rational, irrational and integers. But when we move out from this real number, something exists which is also even bigger than complex number, that means real number. Because when we move out from this real number, something exists which is even greater than real number, that is called complex number. That is called, in Hindi we can say that complex number is real number ka baap. Yes or no? That's in our notes, complex number is represented by Z. That means in the form of Z is equal to A plus iota B. You all have to remember that complex number is represented by Z. That is Z is equal to A plus iota B, where A, B are integers. That means A, B are real numbers and I represent iota. What is iota? Then you can say that a square root of -1 gives iota. Here I gives a square root of -1. Thereafter, when we square both sides, after squaring both sides, we get that I square. I square means -1. The value of I square is -1. Thereafter, IQ means I square into I. The value of I square is -1 into I, that means -I. And thereafter, I to the power 4. I to the power 4, that means I square into I square. The value of I square is -1. The value of I square is -1. -1 into -1, we get that +1. That means after fourth power of imaginary number, we get real number. First thing you have to remember, complex number is represented by Z is equal to A plus iota B. After that, the value of I square, IQ, I to the power 4. Is it right? Is it right? Clear? This concept is clear? Okay. Now let's move. When we take two real numbers, that means A1 and B1, you can say that A1 and B1. Thereafter, we can see that in case of two real number, we can say that A1 is greater than A2, B1 is greater than A2, A1 is equal to B1. That means this concept is called law of trichotomy. Law of trichotomy. Law of trichotomy means one real number can be equal to another real number, maybe greater than equal to another real number, maybe smaller than or equal to another real number. That concept is called law of trichotomy. That concept is called law of trichotomy. But when in case of complex number, this doesn't exist. This doesn't exist because complex number is fully imaginary. So we cannot get that this complex number is greater than this complex number or that is greater than that is. That means in case of imaginary number, it doesn't exist. Let's example two complex number, that means Z1 and Z2. Here I have written Z1 greater than Z2 or Z2 is less than Z1. Its concept doesn't exist, but we can see that two complex number become equal. Two complex number become equal. That means what? That means two complex number Z1 is equal to A1 plus iota B1 and Z2 is equal to A2 plus iota B2 become two complex number are equal when that means A1 is equal to A2. That means real part become equal to real part and B1 is equal to B2. That means imaginary part become equal to imaginary part. So we can say that A1 is equal to A2 and B1 is equal to B2. Here, concept clear? Concept clear? Just note it. Note it fast. First one is I to the power 4. We all have remembered just that the value of I to the power 4 gives 1. The value of I to the power 10, so we can say that I to the power 10 in the form of break in the form of I to the power 4, break in the form of I to the power 10 to I to the power 4. That means we can write that I to the power 4 into I to the power 4, I to the power 4 into I to the power 4. That means I to the power 8 into I to the power 2. I to the power 4 gives 1, I to the power 4 gives 1 and the value of I square gives minus 1, and after multiplication we get that the value become equal to minus 1. Is it right or wrong? It is right. Very good. Thereafter the value of 1 by I to the power 18. 1 by I to the power 18, that means first this I to the power 18 we have to reverse that. That means in case of denominator we move out into numerator. That means it become equal to I to the power minus 18. I to the power minus 18, or either we can say that we have to solve I to the power 18 and thereafter we have to break it down. What I'm saying that I to the power 18 we can break into I to the power 4. That means I to the power 4 into I to the power 4 into I to the power 4 into I to the power 4. That means 4, 4, 8, 4, 12, 4, 16 into I to the power 2. We get 1. Here we get 1, here we get 1, here we get 1, here we get minus 1. I square, value of I square is minus 1. After that, minus 1 into 1, we gives the value of I to the power 18 is equal to minus 1. That means 1 by I to the power 18 gives 1 by I to the power 18 become equal to minus 1. After solution, we get that minus 1. Is it right or wrong? Is it right? Very good. You can write it I to the power 18. Here concept clear. Now you have to mention a note point in your copy that if many terms are repeated in the form of iota with a conjugative integer, that means n plus 1, n plus 2, n plus 3, then thereafter we get value become equal to 0. That means what? That means I am saying that the value of I square plus IQ plus I to the power 4 plus I to the power 5 become equal to 0. That means I 4 value and all the powers are conjugative number 3, 2, 3, 4, 5. We can get answer become equal to 0. That means what? That means we can say that I to the power 399, I to the power 400, I to the power 401 plus I to the power 402. That means what? I am saying that 399, 400, 401, 402, they all are conjugative. We can get the value become equal to 0. Is it right? Very good. Just note it. Thereafter we will discuss a new topic in case of complex number. That means conjugate of complex number. Here we know that complex number is represented by Z. That means A plus iota B. Is called complex number. You know all that. But thereafter we have to represent conjugate of a complex number is represented by Z bar. Z bar is called conjugate of a complex number. Their value become equal to, that means 1 minus IB. That means what? I am saying that just to change the sign of imaginary part, you will get conjugate of a complex number. If you change the sign of negative number, that means use the sign of complex number, that means imaginary part, you will get the conjugate of a complex number. Is it right? Yes, is it right? Conjugate is represented by E. That means if Z is equal to 4 plus 3i, then Z bar become equal to 4 minus 3i. Example, let's take, if you have given that 4i, 3, so we will call that 4i. What is 4i? 4i we can write 0 plus 4i. Is it also a complex number? Yes, this is also a complex number because real plus imaginary. But we can say that here real part is 0. This is purely imaginary. And this is purely real number. And this is purely imaginary number. Purely imaginary and purely real value. Clear? This concept is clear. Now let's discuss another topic of complex number, that is modulus of a complex number. That is modulus of a complex number. Just note it down. Modulus of a complex number. Modulus of a complex number. If a complex number is given in the form of z is equal to a plus ib, then its modulus is represented by mod z. Its modulus is represented by mod z. Its modulus is represented by mod z, and thereafter we will get that the value of mod z is equal to a square root of real part k square plus imaginary part k square. That means a square plus b square. That means a square plus b square. The value of mod z become equal to a square plus b square. Is it right? Is it clear to all? Just note it. Note it fast. Note it. Just to make of here neat and clean, because these all things are important for your examination. From this chapter you will get about 4 or 5 marks in your exam. So this is very precious, this is very important chapter for you. So note it down, jot it down fast. With accuracy is become equal. That means what? If we talk about z, that means a plus ib. When I have found that mod z, the value of mod z become equal to a square root of under root a square plus b square. But after that mod z bar is equal to a minus ib. Mod z become equal to a square real part k square plus minus b k square. That means a square plus b square. We have derived a property that mod z become equal to mod z bar. Now another concept you have to mention in your mind, that under root of minus 1 into under root of minus b become equal to under root of ab. Minus minus become positive AAB. AB minus minus become plus. Minus minus become plus A into B. This concept is totally false. This concept is totally false in case of this concept. Either how to solve? That means we cannot write that. We cannot write that under root of 5 into under root of minus 6 become equal to under root of minus minus plus, or 5 6 are 30. This is totally a bad concept, totally a wrong concept. How can I write? How can I write? I am saying that under root of minus 5, we can say that under root of minus 1 into 5 into under root of minus 1 into 6. Is it right or wrong? Under root of minus 1 into 5, under root of minus 1 into 6. Thereafter, we can say that the value can be transferable minus 1 into under root of 5 into minus 1 into under root of 6. Is it right? Okay. After that, the value of under root of minus 1 become equal to I. That means I root 5. That become equal to I root 6. I square 5 6 to the 30. Here we get that this become equal to I square minus 1 into 30. That means this become equal to minus 30. Is it right? This concept is totally false. This concept is totally right concept. So you have to mention in your mind that by taking an example, we can say that under root of minus 2 into under root of minus 4, we can say that 4 to the 8, but 4 to the 8 but with negative sign. Is it right concept? Okay, this concept is totally a false concept. This is totally a right concept. Just note it. Under root of minus 2 into under root of minus 4 become equal to under root of 8 before negative sign. Is it right? Okay. Now I am saying that another concept, if any complex number lies in a denominator, then how to solve? If any complex number lies in denominator, then what will be the method to solve this question? So first, if any complex number lies in denominator, you have to rationalize this first. This rationalize is very important, because after rationalization, you get in denominator real value. Always remember that in denominator, complex number shouldn't be lies. Complex number lies in the numerator. Okay. Now what will I do? You have to do that rationalization of a plus ib. If in the time of rationalization, just multiply and divide by conjugate of given complex number, that is a plus ib. You have to multiply that a minus ib in numerator and divided by a minus ib. Here what you get? Here we will get that a minus ib in numerator and a plus b, a minus b, that means a square minus b square. A square minus b square means ib square. A minus ib and a square minus the value of I square minus 1 and b square. Here we can say that a minus ib by a square plus b square. That means in denominator we get that real number. In denominator we get real number. So after this type of question you have to rationalize by conjugate of that given complex number. Here this is real. Another concept, take an example. 1 upon a minus ib. 1 upon a minus ib. Then what will the concept? If given a minus ib, you have to multiply and divide by the conjugate of given complex number. That means a plus ib in numerator and a plus ib in denominator. Thereafter we get that a plus ib. That means a plus iota b by a plus b, a square b. That means a square plus b square. Just note it down. Just note it fast. Just note it fast. But after taking example, we can say that example here. Take an example. Here take an example. 1 upon 2 minus 3i. 1 upon 2 minus 3i, and you have to solve 1 upon 2 minus 3i. First rationalize. It is a method. First rationalize 2 plus 3i in numerator, because we have to multiply and divide by conjugate of a given complex number in numerator as well as in denominator. 2 plus 3i. Is it right? Very good. Wow. That means 2 plus 3i. Here a minus b, a plus b, that means a square plus b square. A square plus b square, that means a square, 2 plus square 4 plus 3 square 9. That means 2 plus 3i by 9 4 13. And just separate out real part and imaginary part. That means 2 by 13 plus I 3 by 13. 2 by 13 plus I 3 by 13. This become equal. This is answer. That means this is real part and this is imaginary part. This is real part and this is imaginary part. Just note it down. And such type of question, if given in your examination, then try to solve using this method and using this method. That means rationalizing method. Just note it down fast. Jot it down. Jot it down. Is it clear to all? Is it clear? Is it clear to all? This is part 1. This is part 1 of our complex number. Thereafter, we will come back and just discuss part 2. That means a square root of complex number. How to find a square root of complex number. Some property, parametric form of complex number, and etc. Okay. Now just watch and share and subscribe this channel. You have to must like this video, because I am doing this all only for 1 subscriber. I am giving this education only free of cost. So this is your responsibility to support me. Okay, if you support me, then I will support you, na? So okay, just note it down. We will meet in next video. This is a totally a good concept, and today our motivation thought is that never go with the flow, be the flow. Never go with the flow, be the flow. And honesty once found, it cannot be redeemed. Just note it down. Never go with the flow, be the flow. And honesty once found cannot be redeemed. And our previous motivation thought was that success and excuses never work together. Okay. Bye. Just note it.